All right, let's take a few moments to look at some exponent situations, and I'm going to teach you the basics about what we call a logarithm, where they come from and why they need to exist. Okay, we're going to jump into something that I would think at this point is relatively simple for you to recognize. Okay, if we look over here to the left, 5 to the first power, well, pretty much everybody knows that's just going to be 5. Okay, 5 to the second power, that's 5 squared, that would be 25. 5 to the third power, that's 125. Now that's the kind of things you've been dealing with up to this point, but there's a whole lot of numbers between 2 and 3 that we just sort of skip over and don't account for. And now we're going to start having to utilize them, recognize them, and calculate them. And what I mean is take a look at a situation like this. Okay, 5 to the what power is 40? Well, nobody in their right mind would know that off the top of their head, but you can at least estimate it. 40 ends up somewhere between 25 and 125. So I know this exponent right here is going to be somewhere between 2 and 3. I just don't know exactly where. Now, why would we need this stuff? Well, when you get in the financial realm and you start dealing with a lot of exponential growth situations like investments, you might need to predict how long it would take for an investment to reach a certain amount of money. And there's a good chance that's not going to be a whole number right exactly at 2 years or at 3 years. It's going to be something in between. Or if you're looking at a population and you want to know how long it takes to reach a certain level, well, that's probably once again going to be a decimal. It's not going to, in fact, it's rarely going to be a nice whole value. As you get into real life numbers and statistics, it rarely turns out to be something that is a nice, easy number to work with in your head. So we need a way to approach it. That's where a logarithm comes from. Okay, we've done this in the olden days with some tables of estimations, but nowadays you have a function in your calculator that basically a log button. What you need to know is what it represents and how to use it to figure out something that you can map out and specifically set up to target what you're looking for. Okay, so the basics of logarithms are as follows. Here is a generic logarithm. Okay? And what we need to recognize is that right there, that's your base number. That's like this over here. Those are my base values. This right here is an exponent. That's these right here. Now, this number is what they equal when you put them together. So the first thing we're going to work on when it comes to doing logarithms is to understand them in a format that we would recognize, like this one right here. So b to the x power equals a. This is what we call exponential form. Okay? An exponential form is how your brain usually operates. This is what you'll see in your calculator. We need to be able to go back and forth between those two formats so that we know we're calculating what we expect to calculate. Okay, so the first thing we're going to look at is what exponent do these logarithms really represent? That's how we start this whole process. So if I look at this problem down here, I've got a 3. That's my base. So 3. My exponent would be over here. I don't know that one. So that's my exponent. It's unknown. Equals 81. 3 to the what power is 81? Well, 3 to the 4th power is 81. So what that means is this entire logarithm right here just basically means an exponent of 4. 3 to the 4th power equals 81. All right, let's try that in a couple of other scenarios where it's a little tougher to see. 2 to the what power equals 1/8. Oh, it's a fraction. That means it's been flipped. Okay, and 2 to something equals 8. So if you put those together with your prior knowledge, 2 to the negative 3 would have to equal 1 over 2 cubed, which is 1/8. So my exponent here is negative 3. That's what this entire logarithm represents. And that's how we're going to tell our calculators to set up a scenario that we're trying to target. We have to know what these numbers mean when we type them in, so we put them in the right place. Okay, we look at our last one here. This one looks a little weird. It's got some easy numbers, but at the same time it might be a little tough to recognize. This is basically saying 4 to the what power equals 1. And the only thing that's going to make this equal 1 is something to the 0 power. 4 to the 0 equals 1. So my exponent here is 0. And that's the basics of logarithms. Now, they can get confusing in a hurry. But what we want to do is just always go back to the meaning. If you look at a logarithm like this and you just don't see a number jump out at you, you don't understand quite what it means, it's very important that we try to think about it or write it in these terms. And then usually it's something that we can kind of map out and estimate or calculate right in our head.